Hello everyone. Today you will learn how we can carry out a draft test simulation with SolidWorks. In this simulation tutorials, you will do a draft test analysis of a hard drive. You can download 3D model of this hard drive from our video description link. So after that, open it in SolidWorks and start a simulation study. Click on the simulation tab and start a new study. Give it a specific name, that is the draft test of hard drive. Now you have to select the draft test study. You can see from the specialized simulation, select the draft test. Okay. So we consider that this hard drive is made of a plastic material. So just go to the edit material and from here go to the non-metals, then select the plastics and select the acrylic medium with high impact. Apply, close. After that, we have to go to the setup of draft test simulations. Just right click and define edit. Please note that this hard drive is falling from the height of 2 feet. So specify the draft height and select from the center. There are two options to measure height, that from the centroid or from the lowest point. So this is we will calculate it from the lowest point, that is this point. Select this point and here change the units to feet and enter the value of height, that is 2 feet. After that, you have to select the direction of the gravity. For that, you have to select a face or plane at which the direction of gravity is normal to that plane. So select this plane. Then please ensure that the direction normal to gravity is selected. You can see the arrow showing the gravity directions. And after that, leave other parameters default. Okay. Now go to the result options. From here again define edit and select the solution time after impact, that is 10 microseconds, and save results starting from 0 and the number of plots are 25. Okay. Now run your simulation study and wait until your solution converged. So our simulation has been completed now. You can see the effect of the stresses or stress values at the point of impact. That is the 129.4 megapascal. That is where this is the material yield strength. If we check the stress values in megapascals, you can see so here you can check or see that the material yield strength is 45 megapascal, while the stress occurs at the point of impact is 129 megapascals. You can also show the animations or behavior of this hard drive. Wait until it creates all number of frames. Okay. You can see the times in microseconds. This is the plot step 25. If we click here, this is plot step 24. This is plot step 23, and here its time and its value. Similarly, we can also check the deformations, that the maximum deformation occur here is 0.38 megapascals at the end of 110 microseconds. You can also check the time history graph of displacement as well as stress. So go to the results and select the defined time history plot. So select the nodes. This is the node 1. Here is node 1. We also select another nodes here. This is the node number this with the location of this. And we want to take time on x-axis while stress is in megapascal on y-axis. You can see the stress behaviors of the node 1, that is about here, and the another node that was taken about here, that is the blue one. So this is the time and this is the variation of the stress. Similarly, we can also plot the deformations. Go to the time history plot again and select the displacement. And from the nodes, select the nodes at different locations. Okay. So you can see the deformation behavior. This red one is the deformation of a node about here, another one are here. So in today's lecture, you have learned how we can execute or do a draft test on a mechanical part. Thank you for watching this video.